Now, besides the pure battery-powered version of the remote control, there's also another use case with this where this is used inside the house as a base station, and they tie the remote control for the door lock to a ZigBee module like this so that they can control it with their various smart home devices. So so in this case, we have power all the time, so I don't have to worry about batteries. But the challenge is that the remote works on 3 volts, and the input voltage on this particular board is between 7 and 28 volts. Now it's got a voltage converter, a buck board, buck meaning bring it down. Boost is up, buck is down. And it brings down the voltage to something more reasonable because none of these microcontrollers can run at that sort of voltage. Now, I knew that ZigBees run at 3 volts, so I knew that there had to be 3 volts somewhere on this board. And so I took a look and I found that there are 2 pins. There's actually more than 2, but the 2 primary pins for the voltage into this board, which I know has to be 3 volts, and a ground. Now, ground is technically easy because ground I can almost take from anywhere. I could even tag it into the USB jacket here because basically anything with metal should have a ground. Well, I shouldn't say that. Some of the metal stuff should have ground. This has ground. The can around the chip has ground. But I wanted to keep it relatively straightforward. So if you take a look at the ZigBee spec, it'll show you a certain pinout. Now, be very careful. Make sure you're looking at the module that you are actually using. So I looked up, on this board it has a little label, a ZTL or something like that. And I looked that up. And its pinout is different than the standard ZigBee board's pinout, of course. So that's good. Make sure to go to the spec sheet. It's not a good idea to guess on this stuff. Some stuff like the reset will appear high, but they really aren't high. And if you tie into that's a big mistake I almost made on this one. Is pin 1 on ZigBee is 3.3 volts, but pin 1 here is reset, with high being non-reset, low reset. So if I put a current, if I put a drain on that, it would actually reset this board, and then I'd be like, what's going on? What's going on? So again, go to the spec sheet. That's what's real important. So I found that on this particular board, they had a nice spec sheet, which is good. Pin 8 had power, and pin 9 over here had ground. And also the other thing, be careful with the spec sheets because a lot of their images will show the front side and the back side. Make sure you're looking at the right side because what's, upright and ground on this side, if you flip this board over, it's mirrored. So be cautious with that. Take some time, use your multimeter, do some careful probing. So anyhow, once I figured that out, make sure I wasn't going to blow up this little board, I figured I want to hook up, I need to hook up some wires for the remote control. Now, what I would do, what I started to do is I just had some 10-centimeter wires that I already had tinned and everything. I was going to solder them in. But then I realized, you know what, it's going to be a kind of a drag because sometimes I may want to put these parts together separately. I might want to work on the remote separately from this board. So instead, I used one of these notorious, I don't like them, JST 1.25 millimeter connectors. Now, I'm not a fan of these at all because they're small and finicky and can break. But for a use like this, they're honestly perfect because you can get them in pairs already pre-wired. Like these were already pre-wired, so I didn't have to do the finicky pins. And I could disconnect these 2 units, so I could disconnect the ZigBee from the remote power source if I need to for testing or just manufacturing. So anyhow, in this case, I'm using this connector. It's all going to get tucked inside, so I'm not worried about it. And will give me that flexibility that I know I'm going to need. And you can see I left all the leads long because especially in the beginning, leave your leads long. It's far easier to cut leads back than it is to add. That's for sure. So then the final test here is I hooked up my digital multimeter to those two wires using alligator clips, which again are something that I do not like, but I have them on hand and they're easy to work with, so I deal with it. See, sometimes even if you don't like it, you still deal with it. And here we have our meter, and let's see, it's in auto mode. Let's see, it's kind of floating around right now. That's because I don't have it powered. So let me power it up. And there we go. Now the board is on, and I'm measuring these two leads that are tied into the board, into the ZigBee board, and it's measuring at 3.3 volts. So I got a nice 3.3 volts to work with, and that will be fine for this remote. These devices will usually work between 2.8 volts and 3.6 volts. That's a pretty typical range on these 3.3 volt devices. This remote was probably already undervolted just so that they could use the coin cell. So I've got a good power source now, and I'll be able to tie in and provide power to the remote control itself. This board will always be powered on because it's in their house and plugged into the wall, so I don't have to worry about the battery drain. And then the other part would be the same as the other project. We're switch adapting the two buttons, and that's stuff we've already done, already know, so that's no big deal. So long story short, this is a long video about a little bit of voltage, but it's working fine.